I hope you remember this from college algebra. F comp G, F comp G of X. This is how we read F circle G of X, right? F comp G of X, which is F of G of X. Now, see, there is no power here. It could, but we don't have any powers right now. So we discussed one type of situation in which we have a function to a power. How do we differentiate it? And please remember, n times f to n minus 1 times the inner function prime. Okay, now how do I differentiate something like this? So f of g of x, f of g of x prime. So you see, no powers. This is a slightly different situation. I have to differentiate the outer. This is the outer. This is the first function. This is the closest to x. So this is the inner. So the inner function, and to the inner function, I apply the outer function. If you want an example, I will go back to the power rule for a second. This is the outer, and this is the inner. This will be g of x, 2x squared plus 3, and this is the outer, the square root. So we don't do that right now. We're focusing on, I just wanted to explain which one is the inner, which one is the outer, as an example. So this is f prime of g of x times the inner function prime. But the inner function is g. So this is the general rule, power or no power general rule for the chain rule. Chain rule. Chain rule. Now what I'm getting at is what I just showed you in the right-hand column in the book, in the set of exercises. So if we have f of g, and g is a function of x, and we want to differentiate, what we really want to differentiate is find the derivative of f with respect to x. But I can't go directly to x. I have to first differentiate f with respect to g, and then differentiate g with respect to x. This is another way of writing the same thing. I know it looks confusing, but it's the same thing. Here it says the derivative of f with respect to g. The derivative of f with respect to g. This one is g prime, which we know it can be written as the derivative of g with respect to x. So again, this looks confusing, but it's exactly the same. So I would like to apply this concept in any of the problems that we see here. A simple one. Let's start with 37. In 37, we have y equals 5u squared plus 3u, and we are told that u equals x to the third plus 1. Find dy over dx. So the question is dy over dx. I have several ways. You can say, well, just plug it in. Put u in here and square it. Put u in here and multiply by 3, and then differentiate this. Fine. It's absolutely allowed and perfect. But I want to practice this. So for now, look what happens. I have a function that I want to differentiate with respect to x. But I don't have x in the function. So I have to start by differentiating f with respect to u, and then times du with respect to x. That's all it means. So I determine this, and I multiply them. So dy with respect to u. Moving on to the next page, sorry. Can anyone give us dy with respect to du? Give it a shot. Anyone? Can anyone differentiate this?
10u plus 3.
Exactly. Fine. Excellent. Can anyone differentiate du with respect to x?
3x to the power of 2.
Excellent. Finally, we want to compose this, which is this product. So we want dy over dx, but we cannot have two variables. So the first piece is du with respect, dy with respect to u. It's this one. But this time I have to replace u by x cubed plus 1. So it's this product times this product. But I cannot have two variables in the final answer because the derivative is only with respect to x. So when I write the final answer as this product, I automatically have to replace u by x cubed plus 1. Because I was given from the very beginning that u equals x cubed plus 1. And you can say, okay, wait a minute. Why didn't you just plug it in from the beginning and determine this without having to replace it at the end? Because it's easier to replace it at the end, but you can replace it from the beginning. So can anyone tell us this, replacing u by x cubed plus 1?
Is it 10x cubed plus 13?
Yes, plus 10 plus 3, which is 13, times 3x squared. So final answer would be 30, copy the base, add the exponents, plus 39x squared. Done. So this is the other angle that we have to look at when it comes to the chain rule. And I always want to connect to what's important. I'm trying to make it as interesting as possible for you. So let's look at why. Okay, it's all sophisticated, brilliant, wonderful. Why? Okay, so let's look at a word problem. Why we're doing this? Okay, we want to talk about total cost. We want to talk about total revenue. That's why we're doing this. To know how to differentiate other types of more complicated functions. That's all. That's all we're doing this. Any preference? Is total cost okay?
Yeah, can we do the total cost?
Okay, let's do the total cost, total revenue, total cost. Okay. Solid Seeds Incorporated determines that its total cost in thousands of dollars. So this is 62. So C of x, the square root of 5x squared plus 60. And it plans to boost production T months. Okay, so I have to make sure that I take notes. This is thousands of dollars. Fine. T months. T is in months. Fine. According to the function, x of t equals 20t plus 40. Okay. How fast will costs be rising 4 months from now? So t equals 4 months. Okay. So it's not asking what is the cost 4 months from now. No. It says how fast will the cost be rising 4 months from now. So what are we asked to find? How fast? How fast, which means rate of change. How fast is the cost going up when t is 4 months. So what am I asked to determine? We work for this company. Our boss gives us the function, and it says x is a function of time, c is function of x, but x is a function of time. And it's she is asking us, tell me how fast will the cost due to inflation or whatever other things that happen in the production line or supply chain, whatever. How fast, meaning the rate of change, is the cost increasing 4 months from now? What are we asked to find?
Is it the derivative of
Yes, yes. They're asking us to find C prime when t is 4 months. This is the question. So I have a c of x, and I have x of t. Notice that this is c of x of t, because it's x, but x is a function of t. So this is definitely the chain rule. So how do we start? We are asked to find c prime of t. But I have to find, so c prime of t will be c prime of x times x prime of t. How do I come up with this? From here. C of t. So c of x, c prime of x, and x of t. So I need to determine this, which is c prime of x, and then I have to determine this, which is x prime of t. So, can anyone give us c prime of x? For this, we need the chain rule.
is it 1 divided by 10? Well, it's 2 times 5. Oh, never mind. 2 square root of 5x squared plus 60.
Times the inner function prime.
$10x.
Very good. And I will simplify 2 with 10. And I get 5x over the square root of 5x squared plus 60. So I have this piece. Can anyone give us this piece?
$20.
Excellent. So now we put these two together. So c prime of t will be 5x over this times 20. I cannot put it in because I have to replace x by 20t plus 40. 20t plus 40. 20t plus 40 squared. So, and also times x prime of t, which is 20 times 5, which is 100. I copy that. 20t plus 40, everything over the square root of 5. This square, don't square it, leave it alone. 20t plus 40 squared plus 60. Ah, yes, we had a lot of work here. Only now I can determine c prime when t is 4. So before we do that, let's look at this problem again. we are given c of x, but x is a function of time. So in order to find c prime of t, I have to go through c prime of x first and x prime of t based on the chain rule. C prime of x, you perfectly identified it with something we talked about tonight. Right somewhere here. I don't have them in the correct order. Oh, the square root of the function prime is 1/2 the square root of the function times the function prime. So you said 1/2 the square root of the function times the function prime, which is 10x. I simplified by 2, and I got 5x over this. So we have this piece. This is very easy. It's a linear function. You differentiated this with respect to t, and you got 20. But now I have to put these two together here. So I have 20 multiplied by 5x, and I get 100x. But x has to be replaced by t because this is c prime of t. I can't have x in here. So I replaced x by what I was given. I was given 20t plus 40. And then I replace here, again, x by 20t plus 40, but I have to square it because that's what it is. I found the derivative. This is the rate of change. But what it is at 4, I don't know. I did not calculate this yet, so I have to determine this. Of course, I'm not going to do this by hand. I'm going to put all this as you see it in the graphing calculator. So I'm going to share my screen. Be very careful how you plug it in. You know me, I like to see the function. So I'm going to y equals. You can say, but you only have to plug in one. Yeah, but sometimes they come up with another value and another value. So I prefer entering the function. Be very careful how you enter the function. So it's 100 left parent 20t plus 40. That's not what I meant. Plus 40, close, divided by the square root. I like parentheses, so I'm going to use an extra pair. So 5 parentheses again, 20t plus 40 and squared, and then plus 60, and I close another parenthesis. So make sure that everything is entered correctly. You can check, you can go back and forth, and the top, yes, that's correct. So now I go to second and table, and I punch in all I need, and all I need is 4. And it gives us 44.70. 44.70. We need the measurement unit. Crucial. Can anyone dig deep and tell us the measurement unit for c prime of 4?
Is it dollars per month?
Absolutely. Thank you so much. Awesome. It's c prime. The cost, measurement unit for cost is dollar. The measurement unit for the inner is month. We always have to have 2 measurement units. And the last thing, and I know we have to review all these, but that's why I'm begging you to watch these videos. I know they're not perfect. I know I'm not editing